Okay, here's just a reminder about mixed and entire radicals. Today I tried writing things out ahead of time so that I could talk through them more quickly. I think some of you may prefer like a more concise video, so we'll see how that works. So to differentiate between the two, entire or pure radicals have no number out here. So they have no coefficient that would be on the outside. Everything is inside the radical. For our mixed, they do have something outside. It could be a whole number, a natural number, integer, whatever. It could be a rational number, fraction, it could be a decimal. It could just be a negative sign, because really, what is that? That's a -1. To convert between the two, we've practiced this in class, but there's a quick reminder. If we're going from pure to mixed, we want to take the radicand and we want to factor it. I'm telling you to factor it all the way to prime factors, because that always works. There's never any way to mix that up. So if we have, say, the root of 56, we can factor it into 7 times 8. 8 is 2 times 4. 4 is 2 times 2. Our prime factors are 7, 2, 2, and 2. We would write those under the radical, 2, 2, 2, and 7. And we're looking for a square root, groups of 2, pairs. And those pairs can move to the outside. So this group of 2, 2 2s, will come to the outside, and we'll just write 1 there. What's remaining on the inside, these guys did not make it out. We're just going to simplify back together. So 2 times 7 gets us 14. So here we would say that root 56 is the same thing as 2 root 14. Or we could say 2 times the square root of 14. To go back the other way from mixed to pure, it's faster, I think, easier. We take what's on the outside, square it, move it to the inside. So if there's a 3 on the outside, we'd square it, make 9, throw that on the inside, and then just simplify. 9 by 10, we'd get root 90. So 3 root 10 is the same as root 90. If we have fractions, some people get hung up on fractions, but one technique to maybe make it a little bit easier for yourself is to think of just the top and just the bottom separately. Maybe it helps, I don't know. So if we have here root 75 over 48, we can say just root 75 is the same as, if we factor 75, 3 times 5 times 5. So root 3 times 5 times 5. We've got a pair of 2 5s we can bring out, so that's 5 root 3. On the bottom side, root 48, if we factor 48, that's 2 times 2 times 2 times 2 times 3. We've got 2 pairs of 2 to bring out, 2 of them. So on the outside we have 2 times 2, and we still have a root 3 left over behind. So in a simplified form, on the top we have 5 root 3, and on the bottom 4 root 3. If we have an index that is not blank, if we have a cube root or a 4th root or a 5th root or whatever root, the number of items in the group just needs to match what that index is. So the cube root of 40, we can change to a mixed radical by factoring 40 down to primes, 2 times 2 times 2 times 5. Here we've got 3. We need 3 in order to bring them outside. And 3 2s, we can write that 2 on the outside. So we would say here 2 times the cube root of 5. If we have the 4th root of 810, these are just numbers that are selected at random. Factor 810, that's 2 times 3 times 3 times 3 times 3 times 5. We need a group of 4 in order to break anything out under that radical. So this group of 4, 1, 2, 3, 4, 3s, can come outside and move over there. What's left behind is that 2 and that 5, so they're under there. We simplify, 2 times 5 is 10, so our answer would be 3 times the 4th root of 10. I wrote this out here in quotations just because it's helpful to know how to say it, not just how to write it. Last example here, the 7th root of 384. We just need to factor 384 down to prime factors. 384 is 2 times 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 3. I picked 384 in reverse. This is not a randomly selected number. I took 2 to the 7th power and then I multiplied it by 3, just so I'd have something nice to work with there. So we need 7 identical items under the radical in order to bring them out. So we do have 7 of these 2's. So we can use up all of these 2's, bring them to the outside, and what's left is just that 3, and our answer would be 2 times the 7th root of 3. 2 times the 7th root of 3 and just the 7th root of 384 are identical in their value. They are equivalent. You can write one in terms of the other, and that makes it handy for simplifying different sorts of problems. So as a quick review, I hope that helped.